team has an impressive track record, having advanced to Einstein Field in the last 10 years. With a total of 32 regional winners banners, their dedication and passion for robotics are truly inspiring. Please join me in welcoming Josh from Team 1678 Citrus Circuits. Let's get ready for an insightful section.
Hello.
Hi, welcome.
Let me share my screen and I'll get right into the presentation.
Sure.
All right. Hi, everyone. I'm Josh, and today I'm going to be talking to you a little bit about the autonomous period. It's going to be presented by Team 1678 Citrus Circuits. So first off, in this presentation, what I'm going to be going over is the design of an autonomous routine, how to create paths for an autonomous routine, some details on trajectory following and resources for autonomous routines there, how to tune an autonomous routine effectively, and how to execute an autonomous routine well at competition. So first off, with designing an autonomous routine, I'm going to use Crescendo as an example throughout a lot of this presentation, but a lot of these things I'm talking about should be applicable to for years to come with a bunch of different other games and competitions. Just Crescendo is the easiest example, so you can see how this can be implemented in a real situation. So for evaluating the scoring options in Crescendo in the autonomous period, there were 3 different ways to score points. You could leave the starting area for 2 points. You could score in the speaker for 5 points, or could score in the amp for 2 points plus charging amplification. So a good thing to do is to compare these options to see which one you want to try to achieve the most in autonomous period. So comparing these ones, scoring the speaker is worth 3 points more than scoring in teleop. Scoring the amp is just worth 1 point more than scoring in teleop. Because you can't actually amplify during the autonomous period, then it's much more effective to score in the speaker in auto and then score in the amp in teleop if you want to amplify. It's the most points per note possible, which just increases your point scored. So the optimal way to do it. So you think compare things that way in order to evaluate your scoring options. Another thing to think about is what you're trying to optimize for within your autonomous routine. What exactly are you trying to accomplish? Are you trying to get the most notes possible to increase your point ceiling, to have the highest ceiling possible? Or are you trying to have the most consistent possible autonomous routine to raise your floor? Are you trying to potentially score notes off the midline or a particular note off the midline that's contested? Or are you trying to deny your opponent's notes? And these objectives can really evolve throughout the season as play continues and gets more advanced. So in the earlier events and earlier competitions, it might be more optimal to try to go for the most amount of notes possible because you'll be able to hit that ceiling a lot because there'll be contested notes on the midline still left at the end of the autonomous period or towards the later portions of it. But then later at higher levels of play, those notes on the midline may very well be gone at the and towards the end of autonomous period or even after like the first 5 seconds. So you won't actually be able to hit that ceiling that you've optimized for. So here's an example of a match where our auto optimized for getting to the midline as quickly as possible. Here we are at the bottom right. And you can see in this autonomous routine, we actually drop our preload note instead of scoring it in order to get to the midline as quickly as possible to ensure we're there before the opposing alliance, to get whichever note we want off the midline. And at the end, we're going to go and finally pick up that preload note and score it. This allowed us to get to the midline as quickly as possible. That is what we were optimizing for in this autonomous routine. And then an example of optimizing for denying your opponent's notes is actually from Team 841, the Biomex, who played against us at the East Bay Regional here. You can see them at the bottom left here. They're going to run a disruptor auto to make sure red does not get as many points off the midline and notes there. They're going to just run to the midline and throw a bunch of notes off from where they were originally were. See, this actually causes Team 254 to miss their intake of their next note and actually slows us down as we picked up that note. Team 1678, we still managed to pick up that note, but it slowed us down enough that we won't be able to score our last spike note here at the end of auto. You see, still in our intake when auto ends, we aren't actually able to get the 5 points from it. So it's a very effective auto by Team 841 there to optimize for denying your opponent's notes. Another thing you can do when designing autos is to look around. We have a phrase on Citrus: steal from the best, invent the rest. If another team has already done something really well, we can take inspiration from them to also do a similar thing. So our go-to auto that we used for a lot of the season, I think we ended up using this auto for pretty much every single match in our last off-season event. We took inspiration from Team 2056, shooting one of these spike notes on their way out to the midline. Show you that auto we took inspiration from here. Here's Team 2056, OK Robotics in this corner. They're going to pick up this note on their way out. So they go and pick up that note, score it as they race out to the midline, scoring one of the spike notes on their way out and like saving time. They actually scored 3 notes off the midline. Here they are going for their third. So we ended up taking inspiration from this, but we actually still modified it to more better fit our objectives and optimize it for what our team thought was best. So we added, instead of scoring 3 notes off the midline, we changed it to instead score the other 2 spike notes at the end. So we thought scoring those 2 notes would be more valuable than just scoring 1 note off the midline. You'd see us there running pretty much the same auto. We get that note the furthest of the spike notes there. We race to the midline and we're going to grab 1. Come back and shoot. We're going to grab a second one off the midline, come back and shoot. And then at the end, we're going to go back and score these 2 spike notes instead of going for the midline for a third one. And then we also later modified this auto even further to instead go for the center of the 3 spike notes instead of going for the amp side of the spike notes. We found this was a bit more efficient and allowed us to go for different midline notes a lot easier. Here you can see that being run here. We're at the subwoofer. We score the middle of the spike note, so you see that one is missing instead of the amp side one. You grab 1 off the midline again, shoot it, grab a second one off the midline, shoot it, and then we score the other 2 of the spike notes there. So we modified that even further, which ended up being the auto we ran for pretty much every match of our last off-season event. Another thing to think about when designing is to see whether you can design an adaptive auto routine, which can be very effective. So especially, this is mainly prevalent in years where the game, there's some thing that can be contested in auto, something both alliances can affect, because you're not going to know what your opposing alliance might do. So this can be as simple as detecting whether an action succeeded to choose what you do next. So this can be super easy, like just checking a beam break. That's all you have to do to make an auto adaptive, and still allows many different advantages during auto. So an example of this would be you go to the midline and you try to pick up a note, and then you check your beam break, and you see if you did not actually pick up a note, you instead go to pick up a different note off the midline instead of going back to shoot right away. So you can see an example of an auto like that being run by us at Chezzy Champs. See us on the left here racing 2910 to the midline. See, 2910 gets the midline up well before us. So we are checking our beam break inside of our intake here. We realize, hey, we didn't actually pick up a note. So let's adapt and go for a different note off the midline. So we grab a second note off the midline, return to shoot. And then 2910 comes back for the last note and snags it before us. We finish our routine by scoring the spikes. So that auto allowed us to still score one of the notes off the midline despite being the slower team to the midline and going for the same note in the beginning. So allows us to still get a note when possible. Another way you can make auto routines adaptive is by detecting the next action you want to do, which is a bit more efficient because you can see if the action would fail before you do it. So this is like having a camera and detecting a game piece ahead of you and looking at the midline and seeing, hey, are there any notes left on the midline? I'm only going to go for notes that are still left there on the midline. Another thing you can do with that is you can use on-the-fly trajectories. So if perhaps someone ran a auto that moves one of the game pieces on the midline, you can generate a trajectory that goes directly to that note on the midline instead of to where you thought it should be or where it used to be. And I actually have a video of a good example video of that being run at competition, but here's it being run in our shop here. This auto is designed to go for this note first, and then this note on the edge second. See, it's going to rush forward. It's going to grab that first note. And when it comes back to shoot, actually, our limelight is able to see this area here. And as we're stopping to shoot, our limelight is able to get some good vision readings of where our next note is meant to be. And we're looking over there and we notice, hey, there's no note over here. So we're instead going to adapt and go for this note instead. So as we shoot, we looked over there, and now we go to pick up that note and score that instead. We go back for a preload at the end, of course. Oh, all right. So then there's a comparison of how we decided what auto routines that we should make on our team. Hope you can use see the logic we went through of deciding and then apply that to next year's game and other things deciding for your own team. So how we decided between creating a 7-note auto, which would score the preload note, 3 notes off the midline, and 3 of the spike notes, versus an adaptive 6-note auto, which would score the preload note, 2 notes off the midline, and 3 of the spike notes. We went in and analyzed the different options. With the 7-note auto, the midline note might be gone when we're going back for the third note off the midline because it would take a while to do that. And there might be insufficient time to score the spike notes if we score the spike notes at the end. And if we score all the spike notes at the first, you might end up being really slow to the midline, which we don't really want. But the adaptive 6-note, it would adapt if it misses its first note off the midline. So it would still end up getting 2 in those situations if someone beat us to the midline. There's plenty of extra time to score these spike notes if they're done last. And we also would have some extra time at the end of the auto routine to drive to the midline and end there, ready for teleop. So comparing these two options, the 7-note auto does have a higher ceiling with a maximum of 7 versus a maximum of 6, but it's likely going to be a maximum of 6 in tough matches because there's almost no chance there'll be a note left on the midline when we come back for the third time. And if we get slowed down, there's a decent chance to miss 2 of our notes in auto. So it's not a really very much more risky play, not as effective. It could very well be 4 or even 3 notes in tough matches where we actually care about those notes a lot more. Versus the adaptive 6-note, it's more likely to still get 6 in tough matches. As you saw, if someone beat us to the midline, we could still adapt and go for a second option and still score 6. And also ends near the midline, ready for teleoperated cycles, which shortens our cycle time for the very first cycle, which is always effective and nice. So next, a little bit about creating paths. One very useful thing that's honestly pretty simple is just creating a standardized naming for certain game pieces or what things are on the fields. It allows really clear communication throughout your team. It would allow perhaps the strategy department to easily tell the software department of what paths they want created or what autos they want made. Also allows in software to have a lot less verbose variables. So instead of having a variable that has to describe this note here, like amp side spike note or something like that, you could just use a shortened variable name that goes with your standardized naming conventions. It also makes it a lot easier to coordinate with your drive team. Your drive team can see their list of autos, see whatever options they have, and they know exactly what each autonomous routine will do, where it will go, what it will pick up, things like that. But when creating names, there's some things you should remember to avoid versus alliance relative names. So calling something the left spike note would not be very effective because on the red alliance, the left spike note is this one, and on the blue alliance, the left spike note would be this one. So it would be confusing, hey, which spike note is this one actually referring to? Another thing to think about is you can make it field object relative. So you can name it according the amp side spike note or the source side and make it relative to that because that's consistent throughout alliances. Or what we actually ended up going for this year is making things alphanumeric. So just making the spike notes S1, S2, S3, N1, N2, N3, N4, N5. This is just S for the spikes, N for the midlines, and it's just going 1 through 5 left to right from the blue alliance or 1 through 5 from the amp side to the source side. It's pretty simple and allowed us to have really clear communications and concise variable names. We found it really helpful when designing our autos. Another thing to think about is creating reusable pathing in your paths. It's really effective because if your paths are reusable, you have to spend less time. It costs less time because you have to spend less time coding these new paths, and you have to spend less time tuning these paths as well. It also ends up making your autos a lot easier to make adaptive. I'll get more into that in a little bit. And it also allows you to have a lot of flexibility. So if a lot of your pathing is reusable, you can maybe fit multiple different autos within one single auto file and just pass in some parameters of what paths. And it'll really easily allow you to clean up your code by having a lot less code have to be written. It saves a lot of time. So I'm just going to go in and walk through one of these autos and see how we can reuse a particular path. This is pretty much our go-to auto. We start, score our preload, come out, score this note here, go to grab the note from N1, come back, shoot it, grab the note from N2, come all the way back, shoot it, and then score these two spike notes at the end. But let's take a look at this bolded green path here and see in how many different auto routines can this actually be reused. So this can also be reused in this other auto where it goes for note 3 second here. It can still be reused. Or if we go for note 1 second and we go for note 2 first, come back, shoot, and then go for note 1, this path still finds its way to be reused. And then also if we go for note 3 first, come back, and then go for note 1, come back, it's still able to reuse that path. So right there, that's 4 different auto routines, which can all use that same path. So that's essentially, if all these paths are reusable, that's 4 times less paths you have to write, which saves you a lot of time doing it. But that's just looking at non-adaptive routines. When you look at adaptive routines, this path can get used even more. And let's say you have a routine that goes for N3 and then comes back, shoots, and then goes for N2, comes back and shoots, but it adapts if it misses one of its notes. So let's say note 3 was taken by the time you got there. So you miss the intake there, and then you adapt and go to note 2, come back, shoot that one. But now both of these are taken, so you instead use that path you've already made to go to N1 and then come back. So you can see this path still finds a way to be reused in an adaptive auto, and it's really easy to make this auto adaptive with a path you've already created instead of having to create and tune a whole new trajectory or something. So what we actually found is with only 18 paths, you can get any permutation of scoring these 3 spike notes and then 2 of any of these 3 off the midline. And this includes adapting for missing any intake here. So you could to whatever second choice note you want as well. So if you miss note 1, you could go for note 3 second if you wanted to do that for some reason, for strategy reasons. So just with just 18 paths, it saves a lot of time versus creating every single permutation of this autonomous and then having to tune each individual path in every permutation. It's a lot more time expensive. All right, and another thing about trajectory following, just a few methods of creating and following trajectories. So one of the things that's become really popular lately, it's relatively new-ish, is Choreo. It's a very useful tool for autonomous and trajectory creation and following. What Choreo does is it pre-generates some desired chassis speeds and uses numerical optimization for time to find the most optimal chassis speeds to complete your auto paths in the least amount of time possible. It's also based on personalized robot constraints. So you can input parameters specific to your robot, like the mass, moment of inertia, motor speed, things like that. And it will generate some desired chassis speeds that optimize that path specifically for your robot. So it'll be the fastest possible that your robot can accomplish. It also allows you to input some custom constraints. You can say, oh, I'd like to avoid this area in the autonomous period. So I want to avoid going under the stage or avoid the certain stage legs or something like that. And it can generate paths that avoid those areas. One thing, because it uses pre-generated chassis speeds and the numerical optimization for time is a little resource expensive, then it's actually not very optimized for on-the-fly trajectories, but it works really well for pre-generated ones. Because it has pre-generated chassis speeds as well, it needs some additional control for error correction because it's not going to always be at those optimal chassis speeds. You have to have some way to correct it. So this is just by default PID control with a separate X, Y, and heading controller that you can pass in. It's really easy to make, and it's the pre-generated one. Choreo is also based off distinct time steps, so based off of what time it is after the auto started is where it's how it decides the chassis speeds to go at and stuff like that. Another thing that can be done for path following is pure pursuit. It has to be used in conjunction with some form of trajectory generation. So you have to have some way to generate a trajectory that the robot will follow, and then you can use pure pursuit to follow it. Pure pursuit is essentially PID control to a look-ahead pose. So a look-ahead pose is a position some distance away on the trajectory. And then this distance is adaptive based on your robot's speed to avoid cutting corners at a low velocity. So you can see in this diagram here, you can see the robot looking ahead on the path and purely pursuing that point there. And it causes it to cut the corners a little bit, but it's honestly fine. Just keep that in mind when generating your waypoints and trajectories. It's a really good way to follow a trajectory or waypoints and stuff. So a little comparison of what we've done on Team 1678 and what we found effective over the last season and stuff. So in the beginning of the on-season, we were using quintic hermite splines to generate trajectories, which we found really difficult to use, and they could generate extremely hard to follow trajectories that did not work well with our robot. So we, for the off-season, we ended up switching to a request-based choreo system with pure pursuit error correction. So for this, we had to customize Choreo to work for our request-based architecture. It also had a lot of additional work required to integrate that pure pursuit controller, which frankly provided minimal benefit because the default PID controller is frankly good enough and works well for error correction. The additional benefit from the pure pursuit integration was minimal than just using the integrated PID stuff. So now onto how to tune an autonomous routine effectively. Some things to think about is odometry. Knowing where the robot is on the field is very important for your autonomous routine. This can be done through wheel tracking, which is the most common way to do it. An off-the-shelf resource for this is the CTRE command swerve drivetrain. It's just some pre-generated stuff which you can use to generate both a drivetrain that you can drive for any command-based robot, and it will automatically also give you odometry based off your wheels. A very useful tool there. It also has a way to directly pass in vision estimates to update your odometry pose off vision updates. So vision updates are also very important because with your pose based purely off wheels, wheels can tend to drift throughout a match, or if they scrub and you run up against something, the odometry from those can become very inaccurate. So it's important to update based off vision updates. There's a bunch of off-the-shelf vision solutions now that have come out recently, like Photon Vision, Limelight, North Star, etc. There's so many different options available. And one of the reasons this is very important to have good odometry for is because if you have bad odometry going into your robot, you're going to have really bad trajectory following going out. All right, so garbage in, garbage out. I'll show you an example of that here with us. This is a match of Chessy Champs. We are over here going for our standard auto. You run our auto. You can see we go kind of in between these notes here. It's definitely not the position it's meant to be. We come back, then we go for another thing. It's also definitely not the position it's meant to be, but it just so happens to pick up the note we bumped. And on our way back, we completely run into the stage here. Our wheels are lifted off the ground and they completely move without our robot moving. And then we go back to try to score spike notes, but we're nowhere near them at this point, and we run into the stage again on our way out. So I actually went back after this match and analyzed the log file to try to figure out exactly how it went wrong. So you can see where it went wrong is on our way out. Our cameras weren't actually fully in focus. So around here, they saw an April tag, but then because they weren't fully in focus, they weren't able to tell exactly where that April tag was. So it gave us a vision update that said we were much further to the app side than we actually were. So we thought we were around here where 2910 just took a note from, but we in fact were not. So then when we come back, and then when we go out again, we actually get a second bad vision update, which makes us think we're even further on this side. So our robot thinks it's coming around this back side of the stage here, but we end up running directly into the stage leg, which has our wheels move a bunch when our robot's not actually moving, which completely ruins our wheel-based odometry as well. So our robot thinks it's going for this spike way back here, but as you can see, it is completely off. And then on its way out, it runs into the stage again for good measure. So as you can see, this is why it's very important to have good and consistent odometry to ensure that your robot runs well in its matches. All right. So on to also testing. It's very important to test your autos to ensure they actually work at competition. So the most important thing when testing is to record everything. Record video of every single auto you run. This is very important in case some strange issue comes up in one auto routine and you're maybe not able to replicate it until it comes up again at competition, having video would allow you to figure out what the source of that issue is, and you don't have to spend a lot of time trying to figure out exactly how to replicate it. It also allows you to have essentially a log of what the real robot ended up doing compared to what the robot thought it was doing versus the internal logs you could look at. You can also compile this data really easily with spreadsheets, which is very nice. So you can see here's a spreadsheet here with a bunch of different trials of our autonomous routine, a bunch of different checkboxes to see what the robot did that match, additional comment area. And you can also compile that data to see how effective your different autonomous routines are, their expected accuracy, expected notes per match, which notes they're expected to get, things like that. You can also see how many times we've run it since our last code update to see how consistent they are. Everything like that is very useful to have. If you're running autos that have slightly different permutations, it's also important to check every permutation. So if you have an auto that goes for note 4 and then note 5, or if you have an auto that goes for note 5 and then note 4, it's important to test both of them, even if they reuse a lot of the same paths. You just want to make sure everything has been done properly and something weird doesn't happen that one side works and the other doesn't. So this is important, goes into testing both sides of the field, test on red alliance and blue alliance if your field allows it. I know not everyone has the capabilities to do that, but if possible, it's very important to do so. Just to make sure both your logic and your code to flip based off your alliance is working properly. Then also if there's something asymmetrical about your robot and the field is reflected, that is very important to do. Like an example of that is on Team 1678 this year, our shooter was asymmetrical. It only had wheels on one side, causing the shot to curve one direction. So our shots were slightly different on the red alliance versus the blue alliance. So it was important to test on both sides to ensure we were making those shots in auto on both red and blue. Another thing when testing autos and trying to tune them to make them work is to avoid changing like the waypoints directly. Let's say you have a waypoint directly on one of the notes here, but your auto the robot ends up going way far to like the left of it or something like that. Should avoid just moving the waypoint to the right off of where the note actually is, because that's generally not the source of the issue. You should figure out why your robot did not actually go directly to the waypoint you requested it to go to, or where the error was. To avoid just changing the waypoints, it may seem like a temporary fix, but when you go on a different field on a competition, it might end up being wrong the other way and causing it to run into the wall or have even greater issues. You should nip the issues at the bud instead of just changing the waypoint. Next, onto the execution of an auto routine. Once you've designed a great auto routine, there's still a few key things in order to execute it well at competition and have it perform as best as it possibly can. So one important thing is to know your teammates. On an alliance, all the robots' autos should complement each other. Even if one robot isn't doing the maximum it could do in the autonomous period, it still should be optimized for the entire alliance performing as best as possible. So an example of this being done poorly is our team at Chessy Champs. Show you what happened here. We're on the blue alliance here, right here. We're going to run for our standard auto routine. As you can see, Orbit snagged that note before we could get to it, so our auto instead chooses to go adaptive. So it grabs this note instead and comes back, shoots it, and then because it adapted, it knows both of these notes are gone, so it's going to go for the third note off the midline. And then it tries to cut under the stage to get back even quicker, and it runs into our alliance partner's intake. That was a bad thing to do. We risk damaging their intake, and then we also miss the spikes and risk damaging our intake here. It's not a good thing on our part. So why this ended up happening is because in the off-season, I mentioned how we changed to a request-based choreo system. In moving to that system, we did not integrate a way to stop our autos from going adaptive because we thought, why would we not want our autos to go adaptive? The adaptive is just better, allows us to adapt if we miss an intake. But we failed to consider that the adaptive auto could force us to get in the way of our alliance partners, which caused issues in this match. So what we ended up doing is immediately after the event, we ended up correcting this issue and then adding an option to stop our auto from going adaptive and ensure it goes for if we can restrict it from only going to certain notes and staying away from going under the stage, which we actually ended up coming really in handy at our next event, Madtown Throwdown. Here you can see us here. Basically, about the same thing is about to happen. We're going to go for our standard go to auto. And as you can see, the note gets snagged off the midline well before we get to it. We check our intake, we realize it's not there, but we realize we've gone non-adaptive. So we don't end up actually adapting and going for the second note here. We just go back anyways, and then go for the second note when we come back forward, because we know Madtown Robotics needs to use that space to run their auto routine here. So we don't get in their way, and we're able to successfully go back and actually score the spike notes at the end without interfering with our alliance partners. Another important thing is to know your opponents when running an autonomous routine. This is especially prevalent in elimination rounds when you have a lot more data. You can use your scouting data even after alliance selection, see what maybe your opponents might do in a match. Important things to look at if there's a contested area is to see where they go in that contested area to know where you can maybe target them or where to avoid. And you can also see how fast they are to that contested area. So will you get there before them? Will you be able to snag a game piece out before they get it? Or will they take the game piece before you and it'll cause you to miss? One thing we ended up doing on Citrus is when we qualified for Einstein this year, we looked at all the other alliances on Einstein. We looked through all their playoff matches, our strategy team did, and we timed how long their autos took to get to their midline, and we looked at where each of the robots went during auto for their matches. So we also looked at other Einstein matches to see strategy for later matches. So we looking at Einstein match 3. You see team 604 ran an auto which went for note 4 and then note 5. You see them running for note 4 here. And they come back. And they run for note 5 afterwards. So what we ended up seeing there is we realized, hey, we also timed their auto and realized we were quicker to the midline than them. So if we could maybe get to the midline before them, we can deny them those 2 notes if we also go run a 4-5 in that same order. So you can see our next match, we're up against them, and you can see them rush to the midline, but we get there first. We grab the note, we come back and shoot it. We grab the second note, come back and shoot it. So this was incredibly valuable and allowed us to deny our opponent's points while still scoring notes ourselves there. Thank you. Are there any questions?
Hi, yeah, we have questions in here from the Q&A box. Remember, if you have a question, go ahead. This is the moment. We have a first one from an anonymous attendant. In both the failed autonomous routine videos, it seems you didn't hit autonomous stop from the driver station. Would you suggest any procedure about hitting the button or not, such as if you are sure your robot will crash its intake to the stage, etc.?
With that one, what ended up happening is that there's both the autonomous stop and the emergency stop buttons on the driver station. But one thing we noticed is that also the autonomous stop button has a 1 to 2 second delay based off how they connect to FMS. So if you hit it, it's not going to immediately stop, which if you're planning to stop, that's a good thing to keep in mind. But also with those failed autonomous routine videos, for one of them, we ended up still being able to end near the midline, which would have been more optimal. And we weren't sure exactly how much it was going to fail until it ended up hitting the stage. At that point, it was pretty close to too late. And then the other one, I believe the drive team was unsure. I would recommend making sure your drive team is all on the same page around if this happens, hit the autonomous stop. They weren't aware it was going to happen, and people weren't quite ready to make that split-second decision of going to the right button to hit the autonomous stop. It wasn't too much risk to our robot there, so we thought it's fine to just let it play out, see if maybe it does something good, because we weren't risking getting a penalty in either of those autos.
Okay. Well, we have another question from an anonymous attendant. For your vision processing in Autonomous, what do you do to filter bad April tag position estimate?
So I believe in the on season, I'm not an expert on our vision system, but I believe we used an extended common filter to try to filter out tag estimates. I believe also had some basic logic of if this estimate says we're off the field, it's inaccurate, things like that. I think it was an extended common filter that filtered those out and updated our odometry.
Okay. We have another from Carter. Any tips on learning how to code implement these paths?
Um, it depends on what system you're using. For Choreo specifically, they have lots of amazing documentation and videos. You can find videos online or on Chief Delphi of how to use Choreo paths. They're very useful. There should be pretty good documentation online on how to integrate stuff like that.
Got it. Okay, we have one from Jose. What kind of cameras were you all running and how many of them?
I don't know exactly what cameras we were running. I know we were running two cameras um, looking in slightly different directions on the back of our robot on the shooter side, looking for April tags under the speaker essentially. I know they were running off two Orange Pis. I think there was some version of like a USB camera. I don't know exactly what model off the top of my head. But then we also had a limelight on the front of our robot, which we used as both a driver camera. So we live streamed that to the computer behind the driver station. So a driver could look to see from the robot's perspective where notes were. It was mainly useful for looking around the subwoofer. And then also that limelight was used for note detection in some of our autonomous routines.